Hello, everyone. I'm Magnus, and I'm going to talk a little bit about handling malicious users in a public OpenStack cloud. I'm an infrastructure engineer for a company called City Network that provides a service called City Cloud, which is basically a public OpenStack cloud. It's an infrastructure as a service. We have multiple public cloud sites, 8 of them actually in 6 different countries. Also something called the community cloud, which is basically a cloud service, an infrastructure as a service for businesses that have special requirements when it comes to compliance. For example, financial sector or government agencies and such. We also run a number of private clouds that are based on basically the same technology as the public cloud, but specific for one customer. We also try to build everything on standard OpenStack components as far as it's possible, because we really don't want to get into any vendor lock-in or anything like that, and basically want to use standard components everywhere it's possible. In production today, we run Mitaka, Newton, and Okata. That depends a little bit on where in the upgrade cycle a specific installation is. And we're using OpenStack Ansible to deploy all those environments and use Ubuntu as the operating system of choice. We also do have some environments that are built on CentOS, but we're trying to get everything into the same kind of environment now. So this is what we're going to use. We use Neutron, ML2, and Open vSwitch for networking, and Ceph or NFS for storage. Usually nowadays Ceph, but we still have some legacy NFS-based storage systems. From the beginning, the service was pretty open when we started out with an open City Cloud deployment. You could basically register, you could get an account, you could start using it. Basically the way you would really like it to be all the time. No quality of service, limitations, very liberal quotas, and so on. But that created some problems. We started seeing in some cases, some usage that affected other users of our service. We also saw abuse reports coming in from other networks that our users were attacking other networks and stuff like that. Also, when we started seeing some problems with a malicious user that affected other users, it took very much time to troubleshoot it. It was hard to find which tenant was responsible for it and to be able to deal with it. So basically something had to be done. How do you define malicious use? Intentionally harmful is a good way and basically the definition of the word. Of course, that's a definition. Also, you might have some kind of usage you don't want to, that you don't want your service to be used for. It could be things like spam or other things that might not be illegal, but you still don't want to, you still consider it harmful. But it could be harmful either to us, to our core resources, or other users of our service. It could also be a problem for the rest of the internet if it's our users attacking the rest of the internet. That's of course something we don't want to see. It could also be something malicious from the outside targeting our users. For example, incoming denial of service attacks or things like that. Something you should really think about is the terms of service, to make sure that you can do the choices you want to, and that you make sure that the customer understands what is good and what is good behavior and what is not, and what's acceptable and not. It should really permit the termination of an account or a limitation of a service in case you detect some kind of malicious behavior. And that's important to have it stated in the terms of service so the customer doesn't get surprised or that it affects service level agreements or something like that. You should also consider if there are users you don't want to provide service to, even if not illegal, as I said earlier. For example, spammers or whatever. There might be some users you don't want to provide service to, and that should also be stated in the terms of service. It should also give some ability to analyze things like traffic patterns and usage behaviors. Okay, when it comes to malicious use, some of the problems we see is the classical incorrect user details or payment information. The customer doesn't write the correct information, it's not the correct name, address, and so on, or uses stolen credit cards or the like for payment information. We can also see denial of service attacks and distributed denial of service attacks, both incoming and in some cases outgoing. Or we could see virtual machines in our service that becomes member of a botnet or such malicious networks. There's also the case with intrusions, both attempts and actual intrusions, successful intrusions, that of course also go both ways and can even in a specific situation go both ways. It can be an intrusion from a legitimate customer gets an intrusion to their one of the virtual machines, and then that one is used to attack other networks. And it could be a user that wants to use our service to send spam, for example. Okay, so when you start out to register an account, it will be kind of the normal stuff. You have to enter some information about yourself and contact information, and then you have the payment information. In this case, you can either choose from doing account verification through credit card verification, which is basically just providing a credit card number and that you can reserve as a small amount of money and see that the credit card actually works. And then that's a verification. Or you can do a phone verification, which is basically that you have to call customer support, you have to talk to them and get a code that basically gets you to continue the registration process. There's also something that we call the suspectometer, that is basically some code that analyzes the data that we have available about the customer. All the data goes into this check, and it checks sanity of information, it checks reputation and stuff like that, and returns a value basically based on that information. And that value can, if that value is too high, it will you won't go through with the registration. Sometimes also you can require manual analysis of it if it's somewhere in between. It's kind of inconclusive or it's a little bit suspect, but not suspect enough to just throw it out. Okay, when you have an accepted customer, there is actually an account. You can start spinning up virtual machines and start using the service. It's still interesting to do further analysis, to actually look at the behavior of the user, usage patterns. For example, it could be something that if you know that malicious users often does this or that, this can be really interesting to look at in other users over time. In that case, you can flag suspicious behavior for investigation, either manual or you can flag it for automatic actions. Something that is really interesting to look at there is adaptive limitations, to actually look at the behavior and the usage of the service and adapt quotas and the quality of service limits over time so you can limit damage. It might, for example, be if you start low and then rise it gradually when good things happen with the account, for example. It might be a long time without any abuse reports. It might be that a bill is paid or other things that signals that this is a legitimate account. You can also go the other way around to lower the quotas and the quality of service if you see some kind of suspicious behavior. Of course, to limit the possibility for the customer to do damage, either through using excessive amounts of resources or by using very much resources without intending to pay for them. When it comes to outgoing denial of service attacks, that is basically a customer of ours is doing something bad to other citizens on the internet. This can either be a fraudulently created account that is set up only for this reason, only to be used as a member in a botnet or doing denial of service attacks. Or it could, of course, in some cases be a customer virtual machine that has been compromised and is made a member of a botnet or used for doing denial of service attacks. One important weapon to fight this is to use bandwidth quality of service, to actually set limits so that even if the customer can through a denial of service attack, it won't affect other customers and it will limit the damage as much as possible. This is, of course, a hard line to draw. I mean, you want to provide the best service and with as much bandwidth as possible available, for example, but you still don't want it to be able to either affect other users of our service or make lots of damage to other users on the internet. Something that would be really interesting to be able to do would be to set bandwidth, set quality of service on packets per second also, not just bandwidth. And that's something I don't think Libert supports it even today, so it would have to be implemented there first before you could do it in OpenStack. Of course, except for limiting the damage that it can do, you also want to detect that someone is doing those kinds of things. Either to be able to contact the customer and tell them that, okay, you have a virtual machine here, it's doing bad things, you probably have to want to take a look at it and check in what way it has been compromised. Or to, if it's a fraudulent or malicious user, to shut the account down. For this, we mostly used libvirt traffic counters to be able to measure the traffic that is coming in and out of a virtual machine, and take decisions based on that. For example, sending out an alert if that's called for, or limiting bandwidth further, and so on. You can also look at traffic patterns. I mean, all denial of service attacks are not bandwidth based. They can also be based on vulnerabilities in some protocol. It might be that you're trying to fill up a state table or something like that. So traffic patterns is also interesting to look at. Some things is easier to see on a graph than when you just look at the numbers. So we work really hard on being able to make graphs of every behavior in the environment. For example, this is an example of a graph that shows the top 5 talkers based on packets per second in one of our regions for 6 hours, I think, or something like that. Okay, when it comes to intrusions, I I'm mostly going to talk about the case when a virtual machine or a user, one of our users is trying to attack other networks. It can be everything from scanning for vulnerabilities, and that might, of course, be legitimate if you're a penetration testing company or something like that, but in many cases it's a sign of something going on, but not in itself a ground for termination of the account or something like that. But it's a sign that this is probably something that should be looked into and take a look, is this a legitimate customer or is it not? It's also really important to investigate abuse reports and have a way to match abuse reports to user account. So you can easily see, is this a user that has had lots of complaints, or is it this just one complaint that has happened, and be able to match that and take decisions based on that. Also, it might be interesting to look at traffic patterns. Basically setting up an intrusion detection system that looks not primarily on the traffic coming into customer virtual machines, but rather traffic going out to be able to detect malicious behavior. Then you have the issue with incoming denial of service attacks. In this case, it's not one of our users that is doing anything wrong. It's a legitimate customer that is the target. This you really want to handle as close to the source as possible. You don't want it to get any further into your network than is really necessary. Something that is really important here is to make sure that you have bandwidth available. I mean, if your links to your service providers actually get filled up, you'll probably not be able to handle it without contacting the provider and have them do filtering on their side, and that takes time, so it's usually not an option. So you have to have lots of bandwidth available to be able to handle those kinds of attacks. It's also really good if you can spread the incoming traffic by, for example, announcing a BGP prefix in lots of different locations and then hurl the traffic inside your own network to where it's going. Then if you have an attack of 10 gigabits, you can, and it's spread over 10 different locations, you only have to handle 1 gigabit at each location, which is much cheaper and easier than handling 10 gigabits at one place. You can also use, in some cases, you can use shaping. This, of course, depends on what kind of terms of service you have with your customers and what you're allowed to do when it comes to net neutrality and stuff like that. But in some cases, for example, seeing lots of traffic coming in over NTP will probably be an attack and not something else. And especially to be able to do shaping quickly when you see a traffic pattern that is causing you problems. In some cases, you can also use ACLs, so basically just putting an ACL right in the border. And this is when you see an attack that is coming from basically one location and or that has only one destination, and you really want to stop that specific traffic. That's quite a static way of doing it, but in some cases it might be useful. Basically, you can say that there are two main types of denial of service attacks. Volumetric attacks, that is basically you want to eat as much bandwidth as possible and try to block usage of the services that way. Or the other way is that you try to either affect a protocol by doing something to the server or the service, or you're trying to fill up state, for example, at a firewall or load balancer or something like that to prevent legitimate traffic from coming through. Those kinds of, the volumetric attacks are usually more easy to handle as long as you actually have bandwidth to handle them. But the protocol attacks and the state attacks might be, in some cases, harder. In those cases, you often want some kind of denial of service protection system. And those are available in all kinds of flavors from different companies with different costs and different features. But that's probably something you'll sooner or later have to invest in. And they can basically do it in two different ways. Either all traffic goes through the protection device, and in that case, it looks at all traffic and then filters and don't let the traffic that is deemed to be denial of service traffic through. The other way around is that you analyze traffic all the time and then takes decisions that to reroute certain traffic when attacks occur, and only then send traffic through denial of service protection systems. This is usually something that depends on the scale. If you have very few uplinks to your providers, you'll probably do fine with an inline system, and you don't do that much of bandwidth. On the other hand, if you have a large network with lots of location, you're probably going to need some more distributed system. You can also use BGP blackholing, which is basically a way to, especially if it's remotely triggered, you can send, it's a way to tell your ISP to stop sending certain traffic your way, basically. You can say that, okay, traffic for this IP address should be black-holed at your network. It shouldn't even be sent over the uplinks to us. And this is a really useful way to get rid of unwanted traffic, and especially to make sure that to minimize collateral damage if to other users of our service. Okay, some tips and tricks, or what you would call it. You should really try to automate as much as possible. You will never be able to, I don't think you will be able to automate everything, because some things you will probably have to do manual intervention on. For example, only you can probably know if this is a very important customer that you had a meeting with yesterday, and you've actually met them and know that they are a legitimate customer. No automated system will know that, for example. So some final assessments will probably still be manual, and something that human beings will have to do. But you should really try to avoid that, as both for the reason that response time is so much higher if you have to do a manual intervention. You have to put out an alert to someone. They will either have to hear it or even wake up if you have an on-call service that is at home asleep. And it will take some time until they respond to the threat and actually can do some actions to mitigate it. Also, you don't want to wake up at 3 in the morning because of some kind of attack. It would be much nicer if the bandwidth for that customer is automatically limited a bit. Some kind of warning is sent out to you in the morning when you come in. You will see that, okay, this customer did this during the night. You should probably look at it now in the morning. It's also probably useful. You'll probably want to flag some accounts to always require manual intervention. And that's what I said about, okay, this is a very important customer. You probably don't want your most important customer to be their account to be totally shut down because one virtual machine was compromised by some intruder. So you will probably want some kind of flag for accounts that should be handled more manually. Any questions? Yes?
Do you have to notify customers if they are under attack? Like you mentioned, ABM can be compromised. Do you tell it to the customer?
If we detect it, of course, we tell the customer. I mean, it depends. First of all, it depends on what type of customer it is and what service they are actually buying from us. I mean, in some cases, we might be responsible to actually monitor intrusion detection systems or something like that. And in those cases, we're of course really have to tell the customer if we see some illegitimate traffic or compromises. But in other cases, it might be a user that just spun up a virtual machine. We don't even have access to the virtual machine. We have no idea of knowing what is legitimate traffic or not. If somebody logs in through SSH to that machine from anywhere in the world, we have no idea of knowing is that a legitimate user who is doing that or not. But of course, if we see signs of malicious use, we will contact the customer. We'll analyze the event and see, does this look like a legitimate customer, or is this probably a customer that is a malicious user? And we'll contact the customer in those cases when it's warranted for. Any more questions?
While we were on this, have you discovered any OpenStack vulnerabilities?
Not really, actually. We haven't seen that many attacks that seems to be directed at the OpenStack APIs and so on. It's much easier target the virtual machines that are set up in many cases by customers that have very different types of knowledge about security. I mean, some people just spin up a virtual machine and don't care about setting any firewall filters, or they don't keep their virtual machine patched, or they have a WordPress on it that is 2 years old or whatever. So that's much easier target. But of course, we monitor and keep a close lookout for attempts to exploit vulnerabilities in OpenStack as well. Yes?
You made reference to reputation before. How do you gauge a reputation? Is that IP-based?
It's basically something that is calculated over all the data you have about a customer. It's kind of hard to get into exact details on this, as that might give information to exactly what ways you could get around certain checks. But it's basically an assessment that is done over all the information you have about the customer, including IP, including all the other information you have. Okay, thank you very much.